All right, so the first thing that we need to do is create the equation that relates this information. So it says the weight, so W, of an object varies, so that translates into equals, inversely. So that means we're taking K and dividing by the next number. Okay, and the next is the square of the distance from the center of the Earth. So we'll call that D squared. Okay, so here's the equation that we're using. The next thing that we want to do is we want to plug in our known values for W and D. Okay, so here's the D value, here's the W value that we know. So 220 is equal to K divided by the distance 3978 squared. Okay, so when we solve for this, we multiply both sides by that quantity. Okay, and we have our K value. So right now I'm just going to leave it as this product. I'm not going to calculate it yet. So I get my new equation. My new equation is weight is equal to this number, 3978 squared times 220. And that's all divided by D squared. So here's my general equation. So if I want to see what is his weight when he's 200 miles above the Earth, what do I do with this 200 miles? Is that the D value? No. What do I have to do to find the D value? So now this isn't the weight. This is the distance C is above the Earth, but what does D represent? The distance from the center of the Earth. So what do we need to do with the 200? Add it to this number, right? So I take 3978 squared times 220, and I'm dividing by this 3978 plus 200 squared, correct? So here's my calculation. I'll go ahead and enter that. Okay, so if I take 3978 squared times 220, okay, and I'm going to divide that by the entire quantity, 3978 plus 200 squared. I'm going to put it in decimal form, so I'm going to hit the green diamond, and I get 199.44. Hey, would it make sense that this person would be lighter in space than on the Earth? Yeah.